All right, so we're in the second week of IT 201. So the lab time has been updated. Besides Wednesday and Thursdays, we now have Monday. So here's the afternoon times. Lab time is in this room. There's no classes in this room, so you can come in, you can work. I'm in that office room right there. So sometimes people did use it last week to just do work or what have you. And as they needed me, they just came and got me. And that's how it will work. So as moving forward, especially this week, this will be our first test build in the HIO, the WebGL build. So come in if you get stuck. So the structure of the class is up on the board. So we got week 1 where we did intro to interaction design, Unity, C# scripting. I'll be going over that. Let me know if you have any issues in it. Week 2, we'll be going heavy into user input. And the online part of the class will be moving heavy into raycasting and physics. Basically, stuff that I'm encapsulating and hiding from you, we get to look at more and more in the online part so that you have more functionality that you can mess around with. I'm also going to cover prefabs so that at the end of the class you can see how there's different types of objects you can spawn than just the standard spheres, cubes, and capsules. So hopefully it kind of gives you a little bit more inspiration for anything that you wish to do in these coming weeks. We're gonna, wherever you're currently at, even if it's just a sphere and you're just clicking on it, for this week, that's completely fine to do your test build, even if it's just something like this where it's debug statements. There's no live interaction or information. At this point, this is where I want you to do a test build. You're going to go through the build process. I'll go through this with the online lecture videos. You're going to actually build a series of files. There'll be HTML and JavaScript. You're going to zip them up. You're going to get them up on HIO. And it'll just be a draft state. It'll be private state just for you. But, there's always going to be road bumps, and you're going to have to come in and see me and whatever the issue is. But the benefit of doing it this week is that you're going to be very comfortable that next week you're just going to fine-tune. You're going to build more features. You're going to fix bugs and errors. But you know that the build process will be smooth. You'll be able to get your project up so that for a project deliverable, which is at the end of week 3, really the beginning of week 4. I'll put a deadline, but it's going to be like that Sunday night before we start off on sprint 2. I want you to get your projects up. And I'll put up a post date of Sunday at midnight or whatever it is, but make sure you get it up at that point, because any point after that it's a week late. It's 25% off, and then a week after and a week after. So just make sure you get your projects up. And this is the forum to put them up. This is what my example looks like. Again, every feature, every code I go over in these 3 weeks. So even if it's just something that's rather simple or rather standard to what I made, at least you've went through and did it all yourself. And if you choose to be more expressive than just what I did, then I gave you some additional ideas, features that you can mess with. But it looks like this. There's a project description. It has to deal with just describing what this app is. So last class we went through, I'll just bring that up real quick. Here's all the videos, the live lecture plus the online stuff, which is also why I'm capturing the video right now so that I can post up the live lecture for this week. And remember, I had you just be a user. I had you use a paint program. I gave you a random assignment, a random task. It didn't really matter what it was. Make something. So you spent some time just using an app. Then I asked you to step back, and I asked you to just kind of write out what were these steps? What were you doing? And what were you interacting with? What were you clicking on? What was your input? What tools were you working with? What feedback back to you were the tools showing you? Was the process pretty straightforward? Were you getting stuck? Was there failure points in the user experience? Were you unable to complete the task for certain reasons, certain tools? Or were the tools like so intuitive that you didn't even have to think about the fact that you were using an app? You were just proceeding with the task that you as a user were assigned to do. So basically, I wanted you to kind of like write out your experience as kind of discrete as you could get, because that got us to the point of kind of generating these user flows. So this project description is really like, what is this app? What are you making? Why are you making? Who is the user? What can they do in it? What type of features can they do? How are you making this functionality accessible to the user? Is it directly through input that they're using the mouse, the keyboard, touchscreen? Is there some user interface that they're selecting different options that's changing how they're interacting with the app? Just list out what's happening. And then you get into some more details. This is where your ideas get more refined, get more modular, broken down. As this discretionary, you're able to break stuff apart. That gets you more closer to actually coding. And so it's okay if, first off, this stuff isn't due now. There's no homework that's due. This is all due at the end of the sprint right here. So these documents, they're like living documents. They morph as you learn new things. And then at that due date, you post up what you have. You post up your description, your user flows, your link to your working build. And it's okay if your ideas, your ending result is very similar to mine. What I want you to do right now is like use my app, get some ideas, at least express your own project description. Don't use my words. Use the app, explain it, everything I just explained about it, and then you're going to break down some user flows from it, which I'll get to in a second. Yeah.
Would you expect it to have 3 categories for the diagram?
At a minimum. So my app has 3 user flows. So there's really one primary user flow from my app. So a user flow is just a discrete section of a user experience that has a start and an endpoint clearly defined. It's not the whole app. Whenever you describe the app or build an app, you never focus on the whole thing. The whole point of breaking out these user flows from project descriptions or project requirements is that you're talking about discrete experiences that a user is having with your app. And hopefully it relates highly to whatever the user is trying to get done. And from these user flows, which have discrete areas of the user experience, you can actually think about one part of your code. You don't have to think about programming a whole app at once. You're just thinking, oh, I need a drop down just to switch what primitive the user is drawing. So I don't have to think about how I'm casting out where the mouse position is. I don't think about how I'm changing the scale and the color and all that massive amount of code that needs to get done. I think, oh, all I got to do is how do I change the user shape? That's all my coding assignment is to get done. And I don't have to overwhelm myself. So the core of this is I'm just creating objects. There's really just one main feature of this app. I'm just happen to be looking at where the user is moving the mouse, and I'm spawning stuff. I'm going to show you more interesting stuff to spawn, but I'm just randomly changing the scale and the color. And these objects, the position of the object is being completely dictated wherever the mouse position is. That's it. And in that case, it made sense. Oh, it's a painting program. All right, whatever. You can. It's a whatever you think is. One person wants to like spawn kitchen objects all over a kitchen scene, just cups and saucers. Okay, sure. We'll talk about how you can use the Unity Asset Store. There's a bunch of free models, and you can find vases or cups. And I'm going to show you today how we are going to spawn, kind of create these prefabs, these game objects that live as files outside of your game scene, and you can spawn them. Oh, did I flip it? I flipped it around. Hold on, let me flip it back. And here I'm making a little bit different. The paint stroke is moving away from the user, and it's just kind of creating this custom object that I made with changing colors, shapes, and scales. And notice how they're all like the same. Eventually you can say every time I'm spawning an object, I want every little object within it to be different, have different sizes and colors, and maybe these objects have little behaviors. Maybe they're spawning other objects at different times and they're destroying themselves and who knows what. But notice I'm just spawning a bunch of objects. And later on I get to destroying them because it's too much. Eventually it's going to use up all your memory. So I actually end up destroying these objects later. But the essence is I'm doing this painting program. All I can do is change the shape of it and change the color range of what I'm randomly pulling the colors from. So it's really a painting flow. I have a change primitive flow, and I have a change color flow. Yeah, I have some information up here, and I'm recording where the mouse position is. But that's kind of like passive information. It's not a user flow that's actually of substance. It's not like an interaction point that's changing of input. So you can see like there's a primary feature, which is this painting or this spawning. And these are kind of like secondary features. They're kind of like modifying that primary feature. So I'm modifying the color, I'm modifying the shape, but the core feature happens to be painting. And you can dictate something else. In fact, as you learn more stuff, you'll kind of deviate off of me. But in this case, I got a little painting program. And here are these three, from just using the app, I was able to discern, oh, there's kind of like three features. And that's how I made these three user flows. So there's a painting flow, there's a change primitive and a user interface flow, and there's a change of color. So just within these 3 weeks, you could think about if you wanted to move off me, you will learn you can add user interface features or maybe keyboard shortcuts to change the scale, change the different, you can make all these different interesting prefabs, more combination of geometry that you save out into files. You can spawn different ones. You can select different ones that you wish to spawn or randomly choose from a list of them to spawn from at each point of holding down the mouse button. You can change the position it's being spawned at, the scale, the position. I'm not really going to get into. Yeah, you can make more elaborate game objects like these prefabs. And then in later sprints, you can make them move. You can make them interact with others. Maybe if this one is spawned, it looks at others and it changes the size of other ones that are around it or destroys other ones. You can do quite a bit, and you'll iterate and come up with new ideas that I don't even think of. But this is the stage we're getting it to. So project description, which even if you're making a project that's basically mine, you're going to write your own project description, and the user flow is going to be very different from mine. So that the user flow is your own thought process of what you think is happening at each step of the way of the program. Yeah.
How expansive do you want this to be? The user flow?
Yeah.
You don't want to see a huge app.
No. So this is enough information for me to understand what you're doing and for you to understand how to go about your code. So you don't want to get too much detail because then you're bogged down in the weeds, and you don't want to get too high level that I don't really understand what type of implementation you're going to do. So use this as a guide, and you'll get better as you do it. It's just practice. And again, start it now, and that's why each week as you do it, you kind of, I really didn't scope out this area too much, or this is way too much data, and you'll refine it. But something like this is what I expect. And then you have a link to your project, which mine's I realized how hidden it is. I'm going to update this where it says, like in capital letters, this is the link to my project or something. So it's really easy to find the link. So you got a link, you got your description, you got your user flows. That's it for 2 weeks for this Sunday here. So any questions? All right. So I covered. Oh yeah. So this again, 20% of your grade. Here's sprint 2, another 20% of your grade. Sprint 3, 20%. Sprint 4, 20%, and final exam 20%. And I break up the work each week. You should be able to post it on time so you don't get a late fee. And we're good to go. All right, so week 1, you should have been able to download, install Unity. You should have been able to open up a project. You should have been able to spawn something, 3D object. You should have been able to look around your scene, using either the Alt and mouse, left mouse, or if you like first person movement, like hold down the right mouse button and use WASD. But either way, you should be able to navigate around your scene, which is, as you, the developer, is your camera view in. And then we have the game view, which is the main camera here. Every scene has to have a camera and a light in it, and that these came in by default. And this camera is casting in what we see in the game view. So as I move this object in relation to the camera, this is what the player would see. So know that when you spawn 3D objects in, or anything in really with this editor, they'll get like random information, random numbers put on their position. It's just so that stuff doesn't sit right on top of each other. If you don't want this type of random position, you can just click on this gear and click reset position. It'll just put it at world space 0. There you go. Usually your scene or your objects, it's to make things easy. We look at the stage, we look at world space 0. It's easy to do math, which we'll start doing in a little bit in the code. Notice how the camera is backed off a little bit. It's actually at a space of 10 units off in the Z. So it's backed up so that we can look at world space 0. And it's usually these are the default position of the camera. You can change it as you care to. Just know that it's usually off in the depth, and it's up 2 units. Each unit is a meter. So 2 meters is about 6 feet, and that's about the height of a person. And most games there's a person controller, so that's why it's at this position, and you're allowed to change it as you care to. So we created, I'm going to turn off this script, I'm going to delete these additional objects I was creating, and I'll turn on this sphere, and I asked you to create a folder, a scripts folder, create a script in it, right click, create C# script. This one was called a unit click script. Sometimes you have scripts that you really like and you want to reuse them, and if you do end up duplicating them, so that was Command D or Control D, you'll get an error, and that's because now the name of the file is different than the name of the class within it. So it just, as you duplicate out a script, it just adds a number onto it. So you would actually change the class in the name, in the file name. Just be aware they have to be the same. So in this case, whatever, unit click 1, just update the class name. And as you let it compile, the error goes away. So I'm going to delete that script. So we created that script, and we created, in this case, we're going to place the script onto the object that we want to click on. So I just created this sphere. This is what a game object looks like, all of its information, all of its components in the inspector over here. Each of these are scripts, are sections of code that Unity already created for you, and they're all doing different things. So the anatomy of a game object is here. We're at the top. We can turn it on and off. You can do this with code. This is the name of an object. This is a tag of an object. The only reason I'm going to get into tags is because some of you, for some reason, your main camera was untagged. In the script that we're going to use, it's going to look for the camera, and how it's going to look for the camera is it's going to look for this tag. By default, that tag should already be put on there, but for some reason, a few of you, that tag was not on there. Main camera. So tags are a quick way to search for stuff. We'll do this later, but usually there's names of game objects, and you can tag a whole bunch. So for example, enemy. Where's enemy? Or you tag the player or the main, or you might put a tag on called enemy. That way you can always find all your enemies. Or paint object. You can create custom tags, so we can find all the objects that we're painting with, and you can delete them or morph them over time or what have you. Anyway, this is the name tag, and so every game object has a transform component. This is required. So transform part, module, class has some members connected to it, data members, X, Y, and Z for position, X, Y, Z for rotation, X, Y, Z for scale. There's some other information that you can mess around with that's not shown directly to you through the inspector. But as you move an object, you can see how the position information changes, scaling, rotation, what have you. This just renders the object to camera. But what I'm really interested in is that we created a script, and I'm going to remove the script from the object. You can just drag it on and say, here's custom functionality that I'm creating, the developer. In this case, I created a script called unit clicked. And that's all I have. Got a main camera, a light source, this object in the world that's got this script on it. I'm going to double click on the script. And we have Visual Studio here. We've opened up the size, the scale of the text so it's easy to read. You should be able to, your Visual Studio should be functioning correctly, where if you double click a script, it opens up Visual Studio. If you modify a script and save it, it'll recompile and update in Unity. And you should get all this kind of smart text, all these, it reads in all these different components of whatever these words mean. And so as you're typing stuff, for example, we'll get into the input class. It says, oh yeah, you do mean this input class right here. I can even not fill out the whole word of it, press the enter key, use the dot operator to access data, or to access members of this class, whether it's data, variables, or methods. But I can see everything that relates to the input class. And later on, we're going to use this get mouse button down. But you see that Visual Studio is able to auto-populate in this context-sensitive way. So make sure that this is all working fine, and if it's not, come to lab time. So we have a very basic script here. In fact, let me get rid of this and this, because this we talk about in a little bit. So Unity scripts we're doing with object-oriented programming. Basically, every script is a class. Later on, you might learn to break that convention. But every script is a class, and as you put a script onto an object that lives in your scene, that script is like a blueprint, and it creates an instance of this class with this game object. So I can have multiple spheres, and in fact, we'll get to there, that all connect to this one script and share the same functionality. Yes, there are methods like the start method and the update method in Unity, and we'll get to them later. This is just one method. It kind of simplifies things. And this is a method that's available to you from Unity, and it searches for when a user clicks the mouse on this object. And so this script lives on this sphere object, and whenever my mouse hovers over or figures out that this mouse is hovering over this sphere and I click, it does whatever feature or functionality is within this method. In this case, it's just creating this debug statement. The debug statement gets printed out to the console here. It's super useful to see what's going on in play when you're clicking play and things are active, and you're making sure things are working right. It gives you statements. You can print out variables as their data within those variables are changing. So, for example, here, the position of this sphere is being printed out. Later on, just know that like all this information you can also access in Visual Studio, but there's like a nice, easy way that all the information that's happening, changing, you can access and see in Unity really easily and quickly. So what information are we actually looking at? Let me actually talk about this method real quick. So the components of the method. So void the name of the method, and some parentheses. So when you're declaring a method, you need to declare what's coming in, the input, what's going out, the output. And then what's within the body, the curly brackets, is actually what happens when this method gets called. So void is a return type. It means this method is not returning anything. There's no output. There's no true false statement saying whether whatever we did was successful or failure. There's no floats or vectors being returned back saying we did some math within this method and we did something and here's your result back. So when you might get into this when one method's calling another method and it does something and it gives you back something. That's what the output's for. Yeah.
What's a mono behavior? Did you
Yep.
go over this already?
I talked briefly about it in the first lecture. So we're declaring this class. It's a public class. It means other can see it, can interact with it. We have to give it a name. When we use this colon here, we're saying this class inherits from another class. There's going to be a parent class that we're inheriting variables and methods from. What class is it? It's whatever comes after that colon.
Oh, so it's just another class.
So as I hover over it, it says class UniEngine.MonoBehavior. So this class belongs to Unity Engine, which is a whole library of classes that are accessible to us because we're saying using Unity Engine. And it gives us a bunch of default behavior, like the start method and the update method. And the fact that we can place the script on GameObjects. All of that functionality is given to us through inheriting from MonoBehavior.
Okay. So, what you access this is a Visual Studio.
Right.
So you need Visual Studio to install Unity.
Yes.
I mean, I install Unity.
But when you install Unity, there's an option that says, do you wish to install Visual Studio and the Unity plugin, and it does it all automatically for you.
Yeah.
If you're having issues with that, just come to lab time. Okay. So these methods that MonoBehavior gives you, like start and update, right now I deleted them, but when you create a script, it offers you to them and they're empty. So a start method is called once. It's called right when this script or this instance of this class, I should say, on this game object becomes live. Now, a lot of these game objects right now, you're just building into your scene. They all become live when you click play or when you build the app and the app is run. And whatever the start method is maybe useful for instantiating stuff and creating it for the first time and setting stuff up, and it's run once. Now, later on, we're creating or instantiating game objects at runtime. So game objects will be created later at a later time than when the app is started. And whenever those game objects are first created, that's when that start method that lives in this class, that's a component to this game object, that's when the start method will run. The update method is running as a loop. It runs as quickly as it can, and it just runs through the update whenever you want to make that available on a game object. It doesn't always need to have an update method, but it's common. And it runs as quickly as it can. So it's based on your computer strength, your CPU. It's based on how much content you have running in your app at one time. But it's variable in nature, and it tries to run as quickly as it can. Usually it's like 50, 60 times a second. And it's very useful for user input, which we'll get into next. But for right now, I'm using this built-in method that kind of hides all that stuff from you. And it's doing all that stuff behind the scenes, which we'll see in the next script. And it's just debugging out this statement. Yeah.
So can you write something on Unity without using the Unity library?
Yes, you can. And there's instances to that, but we're not there yet. But yeah, you can. But we're only creating scripts that live on game objects. And you can get into editor scripts and modifying stuff that you're not using Unity Engine. And in fact, there's a whole library for the Unity editor, and there's other areas as well. But we're starting one step at a time. So this debug log, print out this name, which happens to be a string. This name is the name of our game object. And then we concatenate a string. We make it a longer series of characters, a longer text that we print out. This is hard-coded. It doesn't change. This object was clicked, and this world position is this, and then we add the position onto it. So we kind of have two elements which can change, or variable in nature, and one that's hard-coded in. So when I click play, I have clear on play, so all this console stuff will clear out because it's old data. Now when I click on this sphere, it says sphere was clicked and its position is this. This is the XYZ here. So if I move this sphere and click again, the data that's being reported, the position is changed. And that's why we're using the variable. The variable is a holder of data. That data can change, and we're getting a dynamic response here. So what is this information? So this is actually shorthand of saying this.GameObject.name. And this position is this.GameObject.transform.position. So what is that meaning? This is a reference to the object to that this script that this instance of this script, this is a reference to it. So we write this code once, it's a class, it can live on multiple objects. So actually let me duplicate out this sphere and move it around, and let me move a few in a different depths, I should say. So we have a few different spheres here, our game objects. They were all duplicated from the original, which had this unit click script on it. They all share this same functionality. So if I click play, I click on this one, sphere 8, this one here, and with its position, I click on this one back here. That was sphere 11, and this was the position of it, and you can verify it there. So we're saying whatever the instance of this class is, that's this. Whoever is calling this method, which happens to be this class living on, in this case, we have multiple game objects now, multiple instances of this class. So for example, I clicked on sphere 11. If I click on sphere 11, we're saying this instance of the script, this instance of the class, dot find its game object, which in this case is a reference to its superior, to its parent, to its larger data object, which in this case is represented in this inspector as all this information, dot the name of the game object, which if we go up here, I can turn the whole game object on and off. Here's the name of it. I just duplicated it out and it just gives these updated numbers onto it. Sphere 11, which we see was printed to the debug. You know, this is hard-coded. This doesn't change. This.GameObject.transform.position. So it's saying whatever I clicked on, sphere 11, find this, the actual script doing the call, go to its game object. The game object knows the transform component. So we're kind of going up, saying, hey, go find my game object. Now we're going back down. We're going down to a sister or a sibling component. We're saying go find the transform. And then within the transform, go to the position data member of the transform and print that out. And so if I hover over it, you see that it's a vector 3. A vector 3 is just an array or a series of 3 floats. A float is just a decimal number. And the 3 represent X, Y, and Z, or X, Y, and Z position of our object. And notice I didn't have to convert it to a string. I could have been very proper and said toString. So each of these built-in data members like floats and integers and booleans, and now we're dealing with vector 3s, another data structure, has these toStrings, and it basically goes down and it prints out all of its information to a string so that we can access it this way. But all that's hidden from you. It's nicely dealt away with. But it's inherently calling that toString. And also know that this will happen to you too. So if you're in play mode, and it's common to, like, as you're interacting with stuff, you want to move it around to find what's correct, what feels well. Say that this, I end up as I'm testing, I'm like, oh, this is the correct scenario, whatever. and I unclick play, the information gets reset back to whatever it was before you clicked play. So this is an intended feature. It'll screw you up once in a while that before you remember this, that you'll change stuff in play mode and you'll lose the information. It's meant to be able for you to just change a whole bunch of stuff, try and experiment. You don't like it, you unclick play, and everything resets back. But you change stuff in the editor, it'll remember that. So I'll click play, it'll remember that state. So I'll click play and bring it back and it's fine. But if you change one thing in play mode, say I really want this sphere over here, all you got to do is come up to the gear of the component that just had data changed on it. Click copy component, unclick, it pops back, it remembers its previous state, and you can paste. And now it's in that state that you found was the most beneficial state for your user. All right. So that's everything about this unit click script. So I'll click save. Looks like I introduced an error. I'll double click on it. Did I? Oh, I got rid of my ending parentheses there. Put that back. Click save. And I'm good. Cool. So let me delete all these. And now we're going to move to the next stage of interacting. I'm going to turn off this sphere. So that's great. So notice how I duplicate all these spheres. In fact, I had a few hidden. I'll turn these back. So that's great as we're adding content, and but it can get really messy. You have all these objects, and they all are taking care of their own input. And now that not only is that messy, but what happens when we want to spawn new content? What happens when we want to create new objects based on user input or timers or whatever's happening in the dynamic state of the application? Well, usually you want some type of manager objects that control very specific features, functionality, information. So it's very easy to see them at a moment's notice and to open up their scripts and to edit that. So instead of all these objects that we're creating and objects that we're creating during runtime, having all this script and taking control and monitoring their own input, why don't we have a manager object that manages our input for us and simplify this situation? So I'm going to hide those spheres, and I'm going to turn this sphere back on. But I'm going to create a game object, and notice when you create a game object, it's an empty one. Create empty. It gets spawned in, and it has like a random position to it. Just reset the position so that it's sitting nicely at world space 0, and then call it something. In this case, I'm going to have something that's managing the input manager, click manager. Call it something like that. For me, I have this click detector. Notice that as you create an empty game object, all that on it is a name and its position in world space. Even though it's empty, there's no visual information connected to it. Maybe it doesn't make, you don't have to monitor where it is in world space, but just to make things clean, just zero it out. And all that lives on it is our script that's going to deal with our user input. So in this case, I just have one script turned on. In the online videos, we're going to get a little bit more deeper and more advanced with the script, and that's what those other scripts are. So here we have a script. It's just called like whatever the object is. This is our click position manager or input manager, and whatever the script is doing. In this case, we're going to translate from screen space to world space, figure out where that place is in world space, XYZ, and we're going to spawn an object there. So now we have to talk about screen space and world space. So as you move your finger over your phone screen or you move your mouse over your monitor screen, the screen is this kind of flat panel. You can think of it as this piece of glass in front of like an aquarium or some type of virtual world. Even if you're making 2D apps, usually there's this separation of the screen space where your input parts are, whether it's your finger moving across it, a mouse, a controller, whatever. I've got this cursor that's representing where my current input location is in my screen. And then we translate that into our application space, into our world space. So as I look at my app up here and I'm drawing, notice in the top left that I've got this mouse position, I've got X and Y. So as I move all the way to the top here, we have an X of like -8 and a Y of 6. I move all the way over to the right. X went to +8, Y stayed the same. So I move down, X stays the same. Y goes to a negative opposite, -6. And as I move all the way to the left, we have X going back into its negative extreme. Y stays where it is at negative. And if I go toward the center, that's 0, 0. So this is our mapping of screen space. And if I made this full screen, or if whenever you have like something in windowed mode versus like full screen, no matter whatever its proportions or position is on your monitor, its internal like mappings kind of stay consistent. So we have to deal with this fact of screen space, however you're morphing, whatever the aspect ratio is of your app, to what our internal, our application space is, and we're going to call that world space. So we wish to read in the user input, in this case through a mouse cursor, and figure out where we're pointing in world space to either select stuff, create stuff, draw stuff, whatever. And that's going to be a method in here that we're going to use. So let me just start going through this script, and we're going to get to the point here where we're going to acclimate over from screen space to world space. And this is where we're just going to start spawning stuff. So let me simplify, and we're just going to spawn a sphere. So let me just script to compile. And we're just drawing, actually, even this is more, that's the next step. So this distance here, let me just do a fixed distance. We did 5 meters out. So we're going to get to this point in explanation where we can just draw stuff at a fixed distance to the camera. All right. So we name the class. Ignore, these are variables that are declared up outside the method. We'll get to those later. Right now we're just focusing on the method. All right. So one thing quickly to note, I forgot that when methods, we just state the return type, the name, and the input parameters of a method. We don't state anything else. It is implicitly a private method. So everything, whether it's a method, a data structure like a float array, is going to be private, public, or protected. Don't worry about protected. Private and public. Can another class call something on this? Can it change a data member? Then it's public. If it cannot, it's private. Usually you have a few methods that are public that other methods can change stuff, and you control it. You don't let them just change your variables directly. So let me save that. So by default, when you create a script, it says void update, meaning here's an update loop. It's this thing from the Unity engine that lets you run code as quickly as possible in a loop fashion that's on a GameObject. And it's implicitly private, meaning only this class can call it, and there's no input. So within this update loop, which we're going to use, the whole thing is wrapped in an if statement. So this whole code is only executed if this if statement is evaluated to true. If the if statement is evaluated to false, we skip it all. This update loop is empty. It just keeps going. Yeah. Yeah, yeah, right. So we're creating a new script. For me, it's living over here. And we have a few more scripts we're going to cover, but online later. We're not going to get deep into how this is working. The next series of scripts actually get deeper into raycasting physics. We're just covering user input right now. So yes, this is a new script. We created an empty game object. We called it input manager, click detector, click manager. I'm going to delete this one because I don't want it to be confusing. Instead of having all these objects that are checking for input, let's make it easier on ourselves and manage this one facet user input through one object. And we only have one code base that we have to monitor with it. And that's what this one is. These are turned off. That's why there's no click on them. And if you want to make it easier on the eyes, I can remove these. We get into those later. We're just dealing with this one script. Here it is. And we're just dealing with this update loop right now. So you should have like an empty update loop, and you can just write out an if statement with empty brackets, empty parentheses. Yeah.
Are you gonna post the code online, or do we have to write it?
You're gonna have to write it yourselves. I'll go through the videos, and you have to create it yourself.
But on the video, you'll be writing your code. Right?
Yeah, like right now. Right now I'm recording it.
Oh, okay, got it.
So you'll walk through yourself and write the code. So we have this update loop. In this update loop, the only thing that exists is this if statement. Now this if statement needs to evaluate on something. So we can create logical operators, conditions that's like greater than, less than. Booleans are used a lot. In this case, we're using this input class from Unity, and we're going to actually test if the user is clicking the mouse. So if I just start typing out input, it's a class given to you by Unity, and I do the dot operator, I can start looking through it. Here's these get mouse button down, up. These are what we're going to use. Get key up and get buttons we'll use later when we deal with the keyboard. But we're going to be using this get mouse button down. So these are methods. Within those methods, we're passing in an integer. For the mice, anyway, for mouse, we have 0, 1, 2. It's an array of numbers. It's 0 means left mouse button, 1 means right mouse button, 2 means middle mouse button. In fact, touch events on a phone are handled the same way. So if it's reading in one finger, it's actually get mouse button, or it's the same thing. It's 0 means there's one finger pressing. You can check if 1 means is a user pressing two fingers, and it goes up to three fingers. But in this situation, we're checking mouse button clicks. So if you look at the board here, we have get mouse button down only evaluates to true when user first clicks the mouse. If there's no user input, it evaluates to false. If the user is currently holding down the mouse button, it evaluates to false. When the user releases the mouse button, it evaluates to false. So these update loops will run so quickly that there's only one time, one frame, one iteration of this loop that'll return true when the user first clicks. Get mouse button returns true only while you're holding it down. It's false when there's no input at all. It's false when the user first clicks. And if we're only checking the left, it's only reading in the left. And it's false when the user first releases their finger from the mouse button. Get mouse button up is false when you're first pressing. It's false while you're holding. And it's true when you're releasing. So get mouse button down, 0, means we're checking the left mouse button, is useful to read in left clicks. So we can tell right when the user first clicks, and we can say, oh, that was a left click. What do we do when there's a click? So what would get mouse button be useful to check? So it's evaluating to true while the user is holding down the left mouse button, or whichever mouse button you choose to check for. Yep. So drags, if you're into games, auto fire. Anytime you wish to keep evaluating true while I'm holding down. So actually, this is how I'm spawning stuff so quickly, is I'm just holding down the right mouse button. Yeah.
Are you told how many times you check that the user is holding down the mouse button?
You can.
Okay.
But no. Actually, I'll be doing something similar to that with this right here. I'll be changing the distance as the user keeps adding input. He keeps clicking the mouse. But yes, so you can do stuff. So for example, a double mouse click, right? One way of implementing to test if it's a double, not a single click, is you check when the user releases the mouse button. So on get mouse button up, you might say, okay, the user just clicked. Set a timer. So maybe start incrementing a timer. There's a way to check the time in between each update loop. And so you might create a float variable, and you might add that variable time after a user releases the mouse button. And so then you might check for when the mouse button goes down. So if there was an up event followed by a down event within, say, a tenth of a second, a quarter of a second, you might say, oh, a double click event happened instead of a left or a single click event. Last semester we did a space shooter game, and every time you left click, we spawned a laser. That laser game object had some functionality that let it move, and whenever it touched an enemy, it took damage and exploded. So we wanted to not let the user just spam and shoot the laser as quickly as possible, so we set a counter. Every time you press down, you set a float variable to 0, and then you incremented it every update loop. And if you read in the next down, you did a check. Is that timer, is it less? We were doing a quarter of a second. So if that timer is less than 0.25, we did not execute another laser. Only when that number was greater than 0.25 and the user clicked down again, do we say, okay, enough time has happened, reset the timer, execute a laser event, and then that's how you limit a fire rate to a quarter of a second. So yes, you can change. That's the essence of moving off of like hard coding stuff and moving into variables, and you can actually change features and functionality based on time and user input and other events that you set up in your code. And that's where you're going to get to later in the semester. Yeah.
So you said the get mouse button down 0, that's for when you're left click, and get mouse button 1 is for when you're dragging.
So get mouse button is for dragging or for returning true while you're holding down. I'm actually looking at the right mouse button with the 1. So we didn't, first off, you can just look at one statement, right? This logical condition is a little complicated. We're looking at 2 events, and we're looking at an OR. I don't know if everyone's familiar with the OR statement or the AND statement, the double ampersand or the double vertical line. So this evaluates, that says if the user clicks the left mouse button or is currently holding down the right mouse button, either event becomes true, then we execute the code. So if this was an AND, you would have to be holding down the right mouse button and clicking the left mouse button to go into the if loop. So you have ORs and ANDs, and you can make them as complicated as you want, but just start with like one statement. These input, get mouse button down, if I hover over it, you see that its method definition says bool, input.get mouse button down, parentheses, int button. So to use this method, you must call it by its name, input.get mouse button down, and you must send it an integer. You must, in the parentheses, put in an integer. In this case, only 0, 1, or 2 makes sense for mouse button left, right, and middle. And then you are going to receive a bool. How are you going to use that bool? In this case, I'm using it in an if statement. So this update loop is running hundreds of times or 1,000 times a second, and it's constantly just false, 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 false. Once in a while, it's true, and we do that if statement. And then it's either this or that. Yeah.
All these functionality is part of the Unity library, right?
Yep.
The updates.
Yep.
So there is a way to not still manage to
Yeah.
Okay, but I would not do it.
But we're just following every library or system that you're using, whether it's Android Studio or just doing your own C++ programming, you're going to be calling libraries. So even if you're hardcore low-level C programmer, you're calling the standard input library.
Yeah.
And you're still using other libraries. In this case, we're using these libraries of code.
So input is a part of the library's functionality.
Yep. If I hover over it, it says it's a class of type Unity Engine.input. So it's coming from Unity Engine. It's coming from a library that we did not write the code. You're never going to be like going from complete scratch. You're always going to be using libraries. It's useful to dive in a little deeper at a time to learn more what's going on. But you don't start that way. So, update loop, just an if statement. It's only executed if you, in this case, left mouse click or hold down the right mouse click. So I get to show you what it's like spawning objects as I'm just clicking or if I'm holding down. So the only thing, let me return this back. So we need to create a vector 3. We need to create a data structure that can hold in positions because these are the positions that we're going to spawning the objects on. Vector 3. A name of whatever this data structure is because we're going to reference it later. So this is a declaration. And here's the assignment part. Remember, you can just declare stuff and assign it later, or you can do it all at once. So here I'm just declaring a vector 3, which is just 3 floats. Floats are just decimals, numbers. And I'm assigning it to this pre-built vector structure. So if I hover over it, it says vector3.1. Vector 3 is a data structure given to you by Unity. Has a lot of functionality in it that's hidden. Here's a shorthand way for writing vector 3 1 1 1, or x1 y1 z1. There's vector 3.0. So if I just do vector 3 dot, we have back, which is shorthand for saying 0 0 negative 1, and the z down, which is 0 negative 1 0, and so on. There's left and forward, 1 and 0. It's just a shorthand way of, I could just be saying this as new vector 3 1 1 1, actually manually stating what the x, y, and z is. I do f because I'm specifically saying this is going to be a float. So we have integers, we have floats, we have decimals. Floats are not as precise as decimals. We rarely use decimals. You don't need to. Just use floats, and you just say f after it for a float. So you can say, I'm creating a new vector, and I'm placing that information into this data structure. So when you create a float, we could also state this by saying float position x equals 1, float position y equals 1, float position z equals 1, and we can actually place those in. Position z, lowercase. You could also state these floats all at once on one line like this. But I just wrote out each float. You could also declare them like this on one line. But either case, you can create your floats manually, set them to whatever you want. You can use these pre-built vectors, like this vector 1. Just know that you have to use this new constructor. So, for example, floats, integers, booleans are a very simple data structure. You can just assign them information. You can assign them data. But for vector 3s are more complicated data structures. You have to use this. I'm creating a new, it's called a constructor, and there's many different methods, many different constructor methods that are available. In this case, I'm using a constructor method that takes in 3 floats. It creates this vector 3 with these 3 floats in this order. And then this is what I'm using moving forward. It's been assigned, declared, it exists in my memory, and I can keep updating this data location, this data structure with new positions as I'm moving the mouse around. So either case, you can say something like this, or you can use a pre-built one, vector 3.1, which is 111. Either way, just note that these pre-built vector 3s, 1, up, down, 0, they're already built for you. They're already, you don't have to create them anew. You don't say new vector 3.1 because they already exist. They're used so often that they just exist. You can just reference them. Give me this data stored here, put it into my variable. Now I just put a negative in front of it, which just negates each value. So if it's 1, 1, 1, x is 1, y is 1, z is 1, it just negates the whole thing. So -1, -1, -1. And in this example, you could get away with saying, I just want to create a vector 3 and we're going to assign it data later. It's just assigned some arbitrary information. In fact, it's given information that more than likely you will never use later on. So you'll never get, the way that we're assigning this click point, we will never get -1, -1, -1. So it's a safe way to check later on if your data is incorrect or if your algorithm's not processing correctly. If you're getting this negative vector, -1 vector, there's some issue, we got to check for something like that. But in any case, we created this vector 3. Gave it some arbitrary information, and we're going to give it its real information later on. The only thing to note is that this was created within a method. So besides it being private, because we didn't explicitly state it being public, it is actually a local variable. We can only access this within the update loop. If you needed to access it anywhere else in every other method, you have to declare it up here outside of a method that makes it global, and any method in that class can access it. The other situation when you declare a variable in a method like this is it creates it and then destroys it. So every update loop, many times a second, we're creating and destroying this data variable, which isn't the best form. So stuff where you just need to create on the fly once in a while, sure, that's okay. But this is used a lot, so we should probably just create it once. And then in the update loop, we just keep assigning it new variables from the mouse position. And it's more optimal. We're not getting that overhead of creating and destroying a variable many times a second. Yes?
So if it's like it's like a shooter of some sort, and you have bullets, and you create the bullets, but once it hits the target, do you destroy it when it hits the target?
We'll get into that. So there's many different ways to handle that. In fact, what I'm getting to right now, creating a separate prefab, separate game object, we'll get into that. When's this class over? 3:50? Huh? All right, I got 12 minutes. So we create this vector. I told you everything that you really need to know about it. Oh, all this green stuff. So this is what's called pseudocode. These are just notes, comments, directions to myself or others. So before you start coding, you wrote that project description. You tried to get your thoughts down on paper, organized. You tried to get a little more fine detail. You went into these user flows. You actually spent the time to kind of map out these discrete events that make sense per a situation for a user. And from those user flows, you can actually start coding because they're kind of in a very code-based way. Sometimes it's useful to organize your thoughts first on code. So for example, I have this overarching goal of logging the click position in the world space to the console. That's what all the way down here, we do this debug statement and see where it is we're clicking. But even that took a few lines of code. So sometimes it makes sense to get a little deeper. Okay, first I got to create some type of data structure to store this information. So I'm going to create a vector to store the mouse position. Down here, I'm going to actually find the mouse position. Down here, I'm going to actually print it to the screen. So think of writing out if you're getting confused with coding first. So I'm taking this vector 3 and I'm going to assign it some information. So here's where we're going to go find the camera, go find the main camera. There's only one. It's tagged as main camera. If you're getting errors, make sure that that tag says main camera, not untagged. We're going to use this method called screen to world point, meaning go from screen space to world space. How are we going to do that? We're going to feed in some input. Now you're used to the input of using user input. Now we're going to look at the position. So where the mouse is, and you saw as I moved around in my app, it moved the X and the Y position. So we're going to feed that in, which is a vector 3. The first position is X, second position Y, third position Z, which is always 0 because we're in screen space. So to move into world space, we have to add that depth information. Otherwise, we're going to render stuff right on top of the camera. We're not going to see it, or it's going to block our view. So in this case, we're just moving 5 units in the Z in depth. It's hard-coded. Later on, we're going to make it a little more dynamic. And once you get that information, we're going to debug it. We're going to look it to the screen. I'm going to move a little quicker in that we're actually going to create a game object, and we're going to make its position that vector 3, that click position. So we're going to create a variable of type GameObject. So we've dealt with the basics, float and bool. Now we've seen vector 3. Now we see we can actually create data members of type GameObject. We're going to call it a sphere. And then we're going to call this method from Unity, GameObject.createPrimitive. And we're going to pass in what's called an enumerator. Basically, it's a custom-built list of whatever you can select. So in this case, if I just say dot, it gives me my predefined list of what I can pick from. In this case, Unity's primitives of capsule, cube, cylinder, plane, quad, sphere. So I'm going to switch this to cylinder just to show you that you can switch it up. So I'm going to start spawning cylinders, even though my name of my game object is sphere, so it's a little confusing. Maybe I should change the name to something like object I'm spawning. But know that we're going to spawn a cylinder, call it this, which happens to be a sphere, and we're going to go to its transform, then we're going to go to its position, and we're going to set it equal to wherever we're clicking with the mouse. So if I save this and click run, we're spawning, and this is left click, one at a time. And as I hold down the right mouse button, we're spawning many because it's checking every time I'm holding down the mouse button. And if I pull out, it looks like we're spawning this wall of content, this wall of objects. All right. So let's change that up. So this is where we'll do this float distance. All right. I'm going to comment this line out. And I'm just going to put distance here. And if I click play, it's now spawning at 3 units, much closer to the camera. So that's kind of annoying to go back and forth. I can make this public, save it, come back. And if you notice over here with the script, I got a distance now. It's actually showing because I made it public. because this is a Unity object, it's now showing it in the inspector, and I can change it. So let's say I want to go 10 units. Now it's 10 units out. Let's say 20. It's 20 units out. Let's move it back in at 3. Now it's much closer to the camera. So I can dynamically, real-time update that variable. So all I did was add this public float distance change. So now we can actually, every time we click the input, we're going to add distance change to distance. So let me simplify it. For now, let's just say 1. So every time the user clicks, we're going to add 1 to distance. This is shorthand of saying distance equals distance plus 1. Take whatever distance is, add some more to it. Every time we successfully click. So as I'm running it, it's just getting farther and farther away. It keeps adding the distance every time. Now, instead of just even hard coding that, let's make a variable. In this case, I called it distance change. And by default, I just set it to 1. But now, since they're both public, I could say, hey, I want to start my distance off at 3 units. And every time I click, I want to move it out a small amount, 1/3 of a unit. You can click play. That's what it looks like. Be like, that was all right. Let me try 1 unit out. And you can keep updating it very quickly to tune in. And now that these variables are exposed, that's our first step toward connecting it to a user interface and then offering up that feature to the user instead of us. Let them decide. Let's make this a feature, not just hard-coded it. All right. So that was the benefit of making these global variables and then making them public so that they're exposed to the inspector. Our next week is connecting that to user interface elements. So I'm going to very quickly, I'm going to go past, as the 50 mark hits, just hang out if you have questions. This class went a little longer, but I'm going to keep recording because I still have to go into what prefabs are, how you can move beyond just cubes and spheres and what have you. It's going to take me longer than 4 minutes, and you can watch the video if you want to go. So, next step. That's great. So we're going to create some folders. I created this folder called Materials. I created this folder called Prefabs. I can right-click Create to create the folder. So materials are good even if you just want to create. So in this case, I'll create. I did capsules and cubes. I guess I'll go with cylinders this time. So I'm going to create a cylinder. I'm going to reset its position at world space 0. I'm going to hide this other sphere because it's just confusing things. We have a cylinder. I can right-click, create materials, and I've already have several materials. I think I'm running out of color space here. What's the color? I haven't used that. Pink. I'm going to call it pink. I'm going to go up to this color here and make it pink. I'm going to duplicate. I haven't done orange yet. I'll duplicate that. Call it orange. Go up to the color for orange. And you see I just did this over and over again. Got a few colors. So now you can pick one and assign it to this object. And I'm just going to duplicate it. And it looks like I'm looking at it from the wrong angle. I'm going to turn my scene view so that it's looking the same as my game view. Then you can do stuff. You can tweak it. You can rotate, scale. You can add a new color to it. You can make other types of primitives, cubes, and add to it. The end result is just a collection of objects right now. And I'm just kind of positioning them in respect to the camera to see what I like. And I'm kind of working in right in that world space 0. I'm not making things very complicated for myself. All right, let's say I like this collection of objects. So I'm going to make GameObject create empty. I'm going to call it another prefab. I've already done this in the other classes. But some name that makes sense to you. I'm going to reset the position so it's at world space 0. I'm going to take all these other objects and drag them in. Now we have a collection of objects that are parented or grouped underneath a main object. So this is like a hierarchy, and you can nest them and put them all underneath each other, make this whole tree structure. And what gets really interesting is if you do nest them real quick, I'll just drag this one under here. This I forgot to show in the other classes. It rotates off its parent. So you get really fascinating rotations and other types of situations very quickly. And later on, as you spawn stuff, maybe they're kind of rotating slowly or what have you. We'll get into animation later. But let me just leave it like this. Say that this is my object. I have to show the asset store later. There's a whole bunch of free 3D models. Like somebody wants to do this kitchen generator thing, spawning teacups and vases and what have you. Yeah. Oh, I just created an empty game object and just reset its position at world space 0, gave it some type of name that made sense, and just dragged everything underneath it. The end result is it's one thing I can click on. I'm going to go to my prefabs folder. I'm going to drag it in. And what a prefab is it's an external file. So I've taken this game object, I've created this collection of information, I pulled it out of my game scene, I put it on my hard drive. So that's also what these materials are. They're external files. These scripts are external files, but they're just a series of text. If I right-click on this, another prefab, click Show and Explorer, this is an actual external information. And I'm going to pull it into my game as I care to. For me, I'm going to do it based on user input. You can do it based on timers, based on when other information is populated or when other objects are created. They're going to call other game objects or other files. Also, as you spawn these things, you can give them all. You can actually access all these child game objects and give them very unique information. So every time you're spawning it, they have a whole different collection of colors and shapes and sizes and rotations and positions. But in this case, as I spawn it, it's going to be the same information or the same collection. So as you create this prefab externally, this external game object, my internal game object, my game object living in my game scene has turned blue to indicate that it is now a prefab, and this thing has appeared. So even if you're like not happy with it, you're like, oh crap, I really should have done this or that, you actually can go in here and morph it to your heart's content and then say, that's good, I like that, click apply. Or if you made a mistake and you don't like it, you click revert. But it's like a file saving now. So I'm really happy with it. I delete that instance of it in my game scene. So kind of like how classes get instantiated on all these objects. We're actually creating objects that will be instantiated now by our code. So I called it another prefab. So just as you saw how like public variables you can manipulate in the inspector, I can say public game object, variable of type game object. In this case, I'm just calling it fancy. I'm calling it fancy because it's nicer than just a white sphere or something. But when I say public game object, whatever the name is, and I've stated it as a global variable, it sits up here. I'm going to just make it none right now. This is what it looks like when you save the script. It says nothing's connected to this variable. There's no reference to this, whatever this variable is supposed to be referencing. But I'm looking for a type game object. There's actually many, many types of variables, and we'll get into it. But it's saying, hey, I'm supposed to be referencing something, and that something is supposed to be of type game object. So I can just drag my prefab, which is a game object, and say, this is what I'm referencing. Now when I use it later on, instead of just calling Unity's default spheres, I'm going to call this instantiate function. This says whenever this code is run, instantiate or create this game object. And the call to it is the object name, the variable name, the reference, the position, and the rotation. I'll get to why the rotation is like that in a second. But I'm saying, okay, whenever there's user input, create this fancy game object I created at this location, which is dictated by where the user's mouse cursor is, also this depth information I'm giving, and then this rotation, which this means 0 rotation. So as I click play, and then here's my fancy game object doing this creep away, this distance that I've set up. All right, I'll just use a single mouse click because it just spawned a lot. I'll start up here. Now you see that they're just like stamps. They're specific clones. But every time you spawn it, you can give it new information. You can randomize it. You can give it different colors and shapes and growth. It doesn't even need to spawn directly where your mouse cursor is. When it spawns, it can look at other objects around it and manipulate them, change their data, destroy them, or you can do anything that you can think of. So just note that when I start painting, it fills up the scene with all these game objects, and this can get out of hand quickly, and we have to learn how to destroy stuff later. But this is like a whole new level of stuff that you can add to. So even if you just look back at my scene, you should be able to get some new ideas. You can add some new user interfaces. You can spawn some different type of stuff. The only thing I've yet to talk about here is color and how I'm destroying stuff after 3 seconds. The rotation. So quaternion, so you can't just put vectors into rotations. Real quick, it's a math formula that is rather complicated because rotation, if you just use XYZ information, you eventually get to this situation called gimbal lock, where it can't tell which axis it means to rotate, and like the axi will lock on each other. So this happened when they first were developing gyroscopes for aeronautics or what have you. But there's this math function which was created called quaternions, which solves the whole thing, which if you see here, there's this like W attribute. Don't worry about it all. All you have to know is when you're spawning stuff, say quaternion.identity means a default data structure which states a rotation of 0, 0, 0. And later on, there's these things called Euler angles, which make it very easy for you to like say, no, I want to rotate it 45 degrees, and it's really easy by code to just like start rotating stuff. And that is it. Yep. So we've covered everything for the live lecture. We'll get videos like this up. I'm going to go into the asset store. I'm going to have to dig deeper. There's a few more scripts I have to show you that gets into the behind the scenes, what this input is actually doing. It's called raycasting. And I'm going to do a test build WebGL up to itch.io so that you can do that. And then we'll be good for the week. And next week is going to be heavy on user interfaces, all these little white boxes. And then you should be good to build your project. So you can hang out if you have any questions. I'm going to stop the video.